let's go now to part 15. In part 15, we will apply Newton's law of motion or energy conservation principles to analyze circular motion in a vertical or horizontal plane, which is basically motion in vertical loop of an amusement park, ride, rotating cylinder, moving through a leveled or banked curve, and so on, etc. طيب نيجي الآن نقرأ مع بعض السؤال 40. Question 40. السؤال بيحكي لنا perhaps the biggest thrill to be had at an amusement park is on a roller coaster with a vertical loop in it, where passengers feel almost weightless at the top of the loop. Suppose the vertical loop has a radius of 5 meters. What does the linear speed of the roller coaster have to be at the top of the loop for the passengers to feel weightless? Assume that friction between the roller coaster and rails can be neglected. طيب الآن the thing that we should know in this question that if it says weightless or weightlessness, that basically means that the normal force will equal to 0. The normal force will be 0. طيب. Now, if we draw the free body diagram as we have in this image, at this point, we have two forces acting on the riders toward the center of rotation, which are the gravitational force and the normal force. Why? Because the point of contact or the surface of contact in this case will be flipped in the roller coaster. So basically the normal force will be pointing towards the center of rotation. And also the gravitational force is pointing towards the center of rotation. لكن since we have the weightlessness condition, that means the normal force will be equal to 0. So in this case, if we write down the centripetal force equation, F sub c is equal to the summation of forces acting on the object towards the center of rotation, which are basically the normal force plus the gravitational force. And we said in the weightlessness condition, n is equal to 0. So we end up with Fc basically equals to the gravitational force, which is equal to mg. We'll write it down in a minute. Right. Now let's plug in the values of Fc and Fg. What is Fc? Fc is equal to m v square over r. And what is Fg? It's equal to m times g. Now cancel m by m. And to find v, just multiply by both sides by r, then take the square roots for both sides to get v is equal to, now this is equal to r times g. So in this question we have r is equal to 5 meters, so we plug in 5 times 9.81 to get 7 meters per second. Right. Now let's go to the second part, which is the same exact thing that we have in the first part. What speed must the roller coaster have at the top of the loop to accomplish the same feeling of weightlessness if the radius of the loop is doubled? Now instead of deriving the equation, we can simply say that v directly is equal to the square root of r times g. In this case, r is doubled. That means it's 5 times 2. So 2 times 5 times 9.81. And this will give us around 9.9 meter per second. Right. Question 41. This is an important question we have in the book. One of the best or one of the rides found at the carnivals is a rotating cylinder. The riders step inside the vertical cylinder and stand with their backs against the curved wall. The cylinder spins very rapidly, and at some angular velocity, the floor is pulled away. The thrill seekers now hang like flies on the wall. If the radius of the cylinder is r equals to 2.1 meters, the rotation axis of the cylinder remains vertical, and the coefficient of static friction between the people and the wall is μs equals to 0.39. What is the minimum angular velocity omega at which the floor can be withdrawn? Right. Now to solve this question, we have to know how to draw the free body diagram. In this case, we have three forces acting on the riders. We have the friction force upward. ليش؟ لأنه as the rider standing or they are stuck by the wall, the only force that keep them from falling down is the friction force. In this case, it is always against the normal direction of the object. The object or the person should usually go down. فبالتالي the friction force will be in the opposite direction, meaning it will be upward. So we have the friction force upward. This is the friction force. And we also have the gravitational force always pointing downward. And we have the normal force perpendicular to the surface of contact, which is basically at this point, for example, toward center of rotation. Can use this color. I think this is a better one. So this is the normal force. Right. Now, how to solve this question? First of all, we should know that the centripetal force in this question is equal to the normal force. Now, what is the centripetal force? We can write down the equation as follows. We can say that since we know we want to find the angular velocity, so we better say that Fc is equal to m omega square times r, which is equal to the normal force. Right. How can we find the normal force? From writing down the equation on the y-axis, the summation of the forces acting on the y-axis is equal to 0y. The object is not moving up or down. So the friction force is equal to the gravitational force, meaning that we can write F sub s is equal to Fg. What is F sub s? It's mu s times the normal force. What is Fg? It's m times g. We need to find an equation for n. So we can say n is equal to mg divided by us. So we take this value and plug it back to this equation. So we get m omega square phi r is equal to mg divided by us. So we cancel m by m. And now to find omega, we take the square root after multiplying both sides by 1 over r. So we say that omega is equal to g divided by r mu s under the square root. And this is the equation that actually we can always use. Can always use this equation if you would like to memorize it. That will be very simple to you, just to plug in the values that you get in the question in this equation to find the answer. طبعا هو بيحكي لنا المينيمم angular velocity، فبالتالي instead of writing equal we should write what? We should write omega has to be greater or equal to this value. طيب. Now let's plug in the values that we have in the question. We say that it's equal to the square root of g 9.81 divided by the radius of rotation, which is 2.1, multiplied by the coefficient of static friction, which is 0.39. And the answer for this is 3.46 radians per second. Why radians per second? Because we are finding this is omega. طبعا we can also say this is minimum omega. جميل. طيب, now let's go to the next question. The next question is basically what I expect that you will get in the exam. The figure shows a rider stuck to the wall without touching the floor in the barrel of fun at the carnival. Which diagram correctly shows the forces acting on the rider? Again, طبعا we already have the free body diagram for the object or the person inside this ride. بالتالي we choose course A. So let's throw it there. And the answer is A. طبعا, why do we choose this? Because as you can see, it's at this point, so we are assuming it's pointing toward the center of rotation. يعني the center of rotation is at this point. ليش? Your back, basically, if you were the rider, your back will be stuck to the wall and the normal force will be acting perpendicular to the surface of contact towards the center of rotation. So we do not choose E, we choose A. Now let's go to the final question that we have in the MCQ part. This is the multiple choice questions part. هنا بأنه an amusement park ride has the shape of a cylindrical shell of radius 12 meters. First, a passenger stands against the wall of the ride, and when the ride reaches a speed of 15 meters per second, the floor underneath the passenger is lowered. What is the minimum coefficient of static friction that allows the passenger to remain pinned against the wall of the ride? طبعا, we will say use the same exact equation that we have just derived, which is omega equals to square root of G divided by R US. طيب, now since we need to find we need to find the static friction or the coefficient of static friction, and in this example or in this question we are given the radius as well as the linear speed. فبالتالي instead of writing omega in this way, we will say omega is equal to V divided by R, which is all equal to G divided by R times mu S. Now we plug in the values that we have from the question. Say it's equal to 15 divided by R, which is 12, equals square root of 9.81 divided by 12 multiplied by mu S. Then here we just do shift solve, or you can do simple mathematical equation to rearrange this equation and make the coefficient of static friction the subject of the equation. So we get that mu S is equal to 0.52. So the answer is A. Choose A. Sorry. And that's it for the MCQ part. Now, inshallah, we will start with the free response questions part.